Oh, that was a good time to bring back a little free bird here as we start a new chapter. Welcome to our first edition regarding an intro to sequences, and this is a brand new change of mind compared to some of the topics we've been discussing recently. This will be a short 2-week chapter as we come down the home stretch of the second quarter. We're going to jump right in with a definition here. Exactly what is a sequence? I think it's a word we use a lot in our common day experience as it pertains to math class anyway. We describe it as a list of numbers, okay, in a specific order, okay? Just creating a list of numbers in a very specific order, and that's basically all there is to a sequence. It's not the most exciting thing right off the bat anyway, but I think we're going to start to show you some ways where it's really incorporated into a lot of today's society. But the first one I want to throw at you is 3, 8, 14, 21, 29, doink, doink. All right. So what I did is I provided you with the first 5 numbers of a sequence, and then I left the last 2 as kind of a mystery, so to speak. And here's a good example of a sequence. These numbers are in a very specific order, and we're trying to identify the pattern and project what the next 2 mystery terms would be. Now, do you see a pattern? Okay, and this is going to come a little quicker for some than others, but anyway, what you'll notice, to get from 3 up to 8, I added 5. Okay, and then to jump from 8 to 14, I actually added 6. From 14 to 21, I added a 7. To jump from 21 to 29, we added an 8. So what I'm going to do here is I'm going to add 9 to get to the next term, which would put me at 38. And then what I'm going to do is then I'm going to add 10 to get to the next mystery term, which would be 48. So really it's about kind of playing with the different numbers, identifying a pattern. What am I adding? What am I multiplying by? What am I dividing by? Whatever the case might be for a particular pattern. And then project that and continue that pattern forward. Couple more important things to jot down in our notebook, and if I go a little too fast, I really encourage you to make good use of that pause button so you can keep a great notebook with all this stuff included. Each number in that list, okay, is called a term. So we want to just make sure we're using the correct vocabulary. So if you recall that last sequence I gave you, the 3, the 8, the 14, and the 21, and the 29, etc., etc., this rascal right here is called the first term. Now, how are we going to describe that? Let's see. Notationally, we're going to use A sub 1. That 1's a subscript. Your handwriting is going to be very important, and that's simply called the first term. The A is just notationally is called A sub 2. It's called the second term, and then we've got the third term and the fourth term and the fifth term, and all those numbers are supposed to be subscripts. Now, most of these sequences that we're going to deal with, especially the ones we deal with this year in Algebra 2/Trig class, most of these sequences are going to contain what I call kind of a mystery pattern. And the more we practice this, the better we're going to get at identifying the pattern and being able to project it forward onto the next couple of terms. And there's certain fields today, especially if you kind of if you picture working for the FBI or the CIA, and they have a field called cryptology, which basically is all about creating codes that can't be broken. When, for instance, if you type your credit card number online when you did your Christmas shopping, you're doing that with the confidence that nobody else is going to be able to hack in and steal your credit card number and use it for their own purchases. And that's all because of the cryptology work that's out there. So without further ado, we're going to jump into our first example, and the directions are simply asking us to write the first 3 terms of a sequence whose nth term is given with the explicit formula we see right here. Okay, so there's a lot of weird vocabulary there. First of all, you saw this thing called the nth term. All right, that's just our way of kind of generalizing a sequence and putting kind of a formula to it. The word explicit, yes, that word explicit simply means that the A sub n that you see on the left side is strictly by itself and kind of isolated on that left side. It's really not a big deal for us. I just didn't want you to panic if you saw it on the test for the first time. But I really don't want you to worry about that word too much. So anyway, the first three terms, what I'm going to do is I'm going to say, okay, the first term is represented by a sub 1, which basically means we're going to substitute a 1 in for the n that we saw in our formula. And that turns out to be, let's see, 2 times 1 minus 1. I think it's just a 1. And then the second term is going to be represented by a sub 2, and this time I'm going to substitute a 2 in for the n, do a little mental math, and get a 3. And then the third term that they wanted was I'm going to now substitute a 3 in for n, and 6 minus 1 is a 5. So really, if you want to put a little note here in your notebook, it's just about substituting, okay, different numbers in for n. All right, that's really what it amounts to. Just substituting different numbers in for n and keeping track of them. So if we had to write out the sequence, we would say it's 1, 3, 5, dot, 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 and it continues to go in such a pattern. They didn't ask us to go any further than that. For our second example, I want to pretty much use the same set of directions we just had, except I've changed up the formula that was given for the nth term. So if we had to find the first three terms, we would say that the first term, represented by a sub 1, is asking me to substitute a 1 in for that n value. Again, we'll do a little mental math. We'll clean it up. 1 plus 7 turns out to be an 8. So my first term in the sequence is an 8. A sub 2 represents the second term, and now what we're going to do is substitute a 2 in for n. The number's going to get a little bigger. 4 plus 7 is now 11. And then the third term, a sub 3, substitute the 3. And 9 plus 7 is going to be 16. So our series, or I should say our sequence, looks like 8, 11, 16, dot, dot, dot. And those are the first three terms. Our third example's got a little more interesting formula to it. So they've given us an explicit formula here for the nth term, and they're asking me to find the first three terms. And let's see, the first term, and I'm going to substitute not just the first n, but every single n that I see is going to get substituted with a 1. Okay, so we've got 2 to the first minus 3 times 1. I think I got negative 1 there if I did that correctly. The second term, a sub 2, I'm now going to substitute a 2 in for every single n that I see. 4 minus 6 is a negative 2, I believe. And then the last term that we have to find is we're going to substitute 3. And let's see, 2 to the third is 8, 8 minus a 9. We're back to a negative 1. So this is kind of an interesting sequence. Negative 1, negative 2, negative 1, dot, dot, dot. Kind of an interesting series. Just make sure that you're substituting into the appropriate spots. So that was an n, an n, an n, and that changed. And these were n's originally. But you'll notice like the 2 here, this 2 never changed. And over here, this 3 never changed. It's only the n's that are changing values. Okay, this time they're asking for the first 4 terms. Again, they've given us the explicit formula for the nth term of a sequence. A little feistier looking here. And the first term is going to be negative 1 raised to the first power. And then we've got a 1 squared plus 3. All right. Now, negative 1 to the first power is strictly negative 1. And then over here, it looks like we got a 4. Multiply those two bears together. I'm getting negative 4 for my very first term. Our second term, we'll go ahead and substitute a 2. We've got a negative 1 squared. And we've got our 2 squared plus a 3. Let's see, I got a positive 1 here times a 7 there. That's going to give me 7 for my second term. A sub 3. All right, negative 1 to the third, and then I've got 3 squared plus 3. This time I'm going to try to do it all in my head. Well, maybe not. Let's see. I got a negative 1 there, and then this is going to be 9 plus 3. That's going to be a 12 there. So I think I got negative 12 for my third term. I'm going to scroll up just a little bit here. Fourth term is going to be, let's see, negative 1 to the fourth power, and 4 squared plus 3. Now, do you remember we were talking about in the last week when we did our binomial expansion, we said if this exponent right here is an even number, okay, even number, that's going to guarantee that I get a positive answer. And then over here, 16 plus 3 is 19, for a grand total. Multiply those two guys together, we get 19. So the big thing here that's happening is that the signs are alternating, a lot like they did in the binomial expansion problems from last week. So real quick, to put this all together, let's see, we had a -4 up there. Okay, just want to make sure. So we've got -4, comma 7, comma -12, comma 19, comma ... Now, a couple of quick facts here. This is, as we indicated, an alternating sequence. All right, alternating sequence because of the signs that are changing. And it started off negative, and then we had positive, and then we had negative, and then we had positive. The reason that it's alternating is because we had a -1 to the nth power at the beginning. So anytime you see this little rascal sprinkled in a sequence somewhere, you know that the signs are going to alternate back and forth, and we just have to be super careful that we get the right sign when we clean these up. Here's a good example for us where instead of asking for the first 3 terms or the first 4 terms, they just said, hey, give me the 5th term and then give me the 10th term, and those are the only 2 terms we want. So the 5th term is represented by a sub 5. Handwriting is going to have to be extremely important tonight. Make sure your subscripts look like subscripts. If I substitute a 5 in for every n that I see here, I'm going to end up with a 5 over 5 plus 1, which gives me 5/6 as that 5th term. Fast forward all the way to the 10th term. We're going to skip the 6th and the 7th and the 8th and the 9th terms all the way to the 10th term. Now, substitute a 10 in for all of those n's. Clean it up just a whisker. We're going to get 10/11ths for the 10th term. And that's all they're asking for. Just give me the 5th and the 10th term, and that's all they wanted. Okay, now the next part of our lesson tonight, what we finish with, is what I think is the hardest part. In fact, we did something very similar in Calc this year, and they agreed as well. This can be a very challenging topic, especially when you're first introduced to it, but it's kind of a fun puzzle to solve almost. And basically, we're just basically going to work backwards. Instead of giving you the rule or the formula for the nth term, and then asking you to give me specific terms, we're going to do the opposite, and I'm going to give you the terms right up front. I'm going to say the first term's a 2, the second term's a 5, the third term's an 8, the fourth term's an 11, and then the 5th term and the 6th term are mystery terms. So I'm going to kind of give you 2 directions here. I'm going to first ask you to find the 5th and the 6th term for me that are kind of a mystery right now, and then I'm going to ask you to write the formula for the nth term of the sequence. In other words, can you crack the code? Can you identify the pattern and write a formula in terms of n for me? So first of all, what kind of a pattern do you see here? What kind of a pattern do you see? How much are the numbers increasing by? It looks like in order to jump from a 2 to a 5, I had to add 3. And then to jump from a 5 to an 8, I again added 3. To jump from an 8 to an 11, I had to add 3. So you quickly identified that the pattern is simply adding 3 each time. So if I did that, continued that pattern and projected it forward, I would end up with a 14. And then if I added 3 again, I would end up with a 17. So those are my mystery terms. The 5th term is 14, and the 6th term was a 17. Now for the hard part. Can you write the formula for the nth term? That's the challenge. Now, the one thing I want to see you do is I want to see you underneath these terms tomorrow night or tomorrow in class in your homework. The first term is n equals 1. The second term is n equals 2. The third term is n equals 3. And the fourth term is n equals 4. Okay, the trick is, how can I turn, for instance, let's look right here. How can I turn that 4 into an 11? You know, what would I have to multiply it by? What would I have to maybe add to it? What would I have to subtract to it? Questions like that. Now, I have to use the same formula over here if I want to turn a 3 into an 8. And over here, it has to work here as well. It has to turn a 2 into a 5, all right? But basically, that's what I want you to write down here. We need to somehow transform or turn that 4 into an 11. And then that rule has to work for all the other terms as well. So I'm going to kind of cut to the chase on this one and see if you agree. I'm going to say, for instance, take the 4 here, take that 4, triple it. In other words, multiply it by 3 and then subtract 1. Would that give you the 11 we have standing in front of us? I think it would. Now take that same rule and use it back here on the 3 perhaps. triple that 3, which would give you 9, and then subtract 1. Bingo, we got our 8. So forth and so forth. I think it would work on each and every term. So I'm going to make a prediction that my nth term is 3 times the value of n minus 1. In other words, we're tripling the n and then subtracting 1. Now, my advice here, before you move on and assume that we're right, is I want you to test this theory. For instance, this is n equals 5 and that's n equals 6, correct? I want you to test that theory. I want you to substitute a 6 into my formula. A sub 6 equals 3 times 6 minus 1, 18 minus 1. Yes, it's a 17, and I'm really happy about that because it matches the 17 I had right there. So that tells me that this formula works, and this is the formula right here for the nth term. Right here is my final answer. What I have down here, that's considered my check, okay? That's considered my check. All right, a little more exciting challenge here. The same set of directions that we just saw in the last problem. First thing I want you to do, we'll kind of consider it part A, is to just find out who the mystery 5th term and the mystery 6th term are. In other words, can we find the pattern by looking at just the first 4 terms and then project that pattern forward and find the 5th and the 6th term. And then part B is we're going to try to write the formula for the nth term. All right, for starters here. Let's see. Sometimes it's easier to just simply focus on the numerator or the denominator only. Now, as far as I was concerned, I looked at those numerators and I instantly found a pattern in those numerators. It looked like in order to get from the 1 to the 7, I had to add 6. And then to get from 7 to 13, I had to add 6. And then to get from 13 to the 19, I again had to add 6. So I'm going to continue to do that. My next numerator is going to be 25, and then my next numerator after that would be 31 if I continue to add 6 each time. Now it looked like my denominators here were going up by 5. So 5, 10, then a 15, and then a 20. So I'm going to say my next denominator is going to be a 25, and my next denominator after that will be a 30. So those are my next 2 mystery terms. We could simplify that 5th term if we wanted to, but it's actually not required on one like this, probably. But the real challenge comes next, where we're going to identify a rule or a formula for the nth term. And I want you to make a note here. N equals 1, n equals 2, n equals 3, and n equals 4. If you want to try to solve this one on your own, I'd really be impressed with that, and I encourage you to do so. Go ahead, hit the pause button, and see if you can write the rule for the nth term. I think it'd be an exciting challenge. Otherwise, stay tuned, and we'll solve this one together. Okay, so now we're back, and I'm kind of curious to know if anybody had any luck on their own, and see if you kind of came up with the same thing I did. So let me know in class tomorrow if you got this all by yourself, and I'll give you a big high five. But nonetheless, I thought the numerator was harder than the denominator. I kind of jumped on the denominator early. But as far as the numerator goes, let's see here. I don't know why I like to start with the 4th term. Usually bigger numbers are a little... I don't know. I guess experiences led me to this term. The numerator, I said to myself, it's kind of trial and error because, a trick that might work for that 4th term may not necessarily work for the 3rd and the 2nd term, and that's probably the biggest challenge is we have to create a formula that works for all the terms just the same. So I said to myself, well, you know what, I could take that 4, and I want to try to turn it into a 19. Well, I could maybe multiply the 4 by 5 to give me 20 and then just subtract 1. The problem is, if I come over here, if I multiply the 3 by a 5 and then subtract 1, it doesn't quite give me the 13. Okay, so I had to go back to the drawing board, start all over, and see if I could get a new one. So anyway, here's what I came up with. I said, you know what, if I take that 4, if I multiply by 6 and subtract 5, then I'll end up with the 19. So did you catch that? I'm going to multiply by 6 and then subtract 5. And I'm going to test that theory on all of these terms, okay? So here's what I'm proposing. I'm going to multiply the n value by 6 and then subtract 5. And I just need to test that on some of the other terms. For instance, does it work with the 3? Let's see, 6 times 3 is 18, minus 5 is 13. Yes. All right, it works. Come over here, test that 2. 6 times 2 is 12. 12 minus 5 is 7. Yes, check. Come over here, test the 1. 6 times 1 is 6, minus 5 is a 1. Yes, check. Okay, so it's looking pretty good, and we got some faith there. Now on to the denominator. I thought this was a little easier. All we're simply doing is multiplying the n value by 5, and that's it, period. We're done. So 4 times the 5 is the 20. I'm going to go ahead and write that down. 5 times the n value. Over here, we'll test it right here. 5 times the 3 is 15, check. Over here, 5 times the 2 is a 10, check. Over here, 5 times 1 is 5, check. All right, looking pretty good. Last thing I want to do is I want to kind of really give it the ultimate test. This right here was the 6th term. So I'm going to test it here. I'm going to say the 6th term is 6 times 6 minus 5 all over 5 times 6. So I just substituted 6 in for my ends. Let's see, 36 minus 5 is 31. All over 5 times 6 is 30. Wow, yes, it worked. We got a match. So that tells me right here that this is a good formula for the nth term. Okay, last one of the night. So hang in there, a little more practice, and we'll gain some confidence in these problems. As far as identifying the next two mystery terms, I really like the numerators. You'll notice the numerators are not changing. The numerators look like they're continuously going to be a 4, so I just filled those in. On the denominators, it look like they're simply adding 3. So the next denominator would be 13, and the next denominator after that would be 16. Now for the real fun part, we're going to try to write a formula, an explicit formula for the nth term. And we notice here's my first term, here's my second term, here's my third term, and here's my fourth term. And again, the challenge here is can we turn that 4 into this fraction right here? Now as far as I'm going to just jump right to it here. I love the numerator. The numerator is our best friend. The numerator is guaranteed to be a 4 no matter what. In other words, the numerator is independent of the value of n, or the value of n has no impact or effect on the numerator, so it's just strictly 4. When we look at that denominator, what if I tripled the n value and then I subtracted 2? What if I tripled the n value and I subtracted 2? Would that work? Let's see. So we're going to check this rascal right here. Multiply the 3 times the 4 and then subtract 2. Yes, gives me 10. All right, let's check this one. Multiply 3 times 3 and then subtract 2. Yes, we got a 7. All right, multiply 3 times 2 and then subtract 2. Check, we got a 4. All right, check this one. 3 times 1 minus a 2. Check, we got a 1. All right, now for the real test. This over here was my 6th term. Let's see, a sub 6. Let's go ahead and substitute a 6 in for that n. And we've got a 4 all over 3 times 6, 18. 18 minus 2, 16. Woo, baby, look at that. We got ourselves a match. That's good stuff right there. So we know with confidence that this right here in this box is my final answer. That's an explicit formula for the nth term. Now, if those last 3 problems were a little more challenging or a little more than you bargained for, I don't want you to lose any sleep over that. That's not going to be a problem for us tomorrow. We're going to continue to work on those. But I think early on in today's lesson, I hope you really felt confident with those first 3, 4, 5 examples we did. And those are the ones we really got to nail down before you come to class tomorrow. Good luck. We'll see you tomorrow.